Okay, good afternoon all of you. In today's session we are going to discuss about the two different types of voids which you can have in crystal systems. So first, the first one is called tetrahedral void. So tetrahedral void means there will be three spheres, okay, and if you join their centers you will get an equilateral triangle. So there will be three spheres, and then on top of them there will be a fourth sphere like this, okay. So there will be three spheres, 1, 2, 3, and on top of that there will be a fourth sphere, and in the middle we will get a tetrahedral void. And the other option is that you will have three spheres in the lower layer, okay, and you will have three spheres in the upper layer. So three in the lower layer and like 1, 2, 3, and these three will be in the upper layer, and the gap between them, that is called octahedral void. So there are two types of voids. One is tetrahedral void, and so that is formed by four spheres, three in the bottom and one just above them. And the other is octahedral void. This is formed by six spheres, three in the bottom layer and three just above them. So these are the two types of voids. Okay, now what happens is that there is a rule So there is a rule that the number of octahedral voids is equal to the number of constituent particles. So that is rule number 1. And second rule is number of tetrahedral voids is equal to twice the number of constituent particles. So these are the two rules. First rule is number of octahedral voids equal to number of constituent particles, and second rule is number of tetrahedral voids is twice the number of constituent particles. So these are the two rules related to the number of voids. Okay, now regarding the size of the void, so So for octahedral void, I have drawn the four spheres at the bottom. I have drawn one sphere of small radius r. So from this triangle, you can see that this side is small r plus big R, this is small r plus big R, and this is 2r. So we can use Pythagoras. 2r square is equal to small r plus big R whole square plus small r plus big R whole square. So small r plus big R is capital R root 2. So 1 plus small r by big R is root 2. So small r by big R is root 2 minus 1. So that is 0.414. You see, generally what happens is that cations are smaller than anions. So generally this void one will be a cation and these will be the anions. So we can also say small r by big R, we can also say is the radius ratio of cation is to anion. And another thing is that in octahedral void, the coordination number means number of immediate neighbors. So coordination number literally means number of immediate neighbors. So that is equal to 6. So coordination number of immediate neighbors, that is equal to 6. Okay, next we come to tetrahedral void. So these are the 3 along the body diagonal. So 2 into capital R plus 2 into small r is equal to a root 3. And one more thing is 2 into capital R will be equal to a root 2, because there will be one particle here. So 2 into capital R will be a root 2. So if you divide these two, then smaller by big R is root over 3 by 2 minus 1, which is coming to 0.225. It is coming to 0.225. And here the coordination number is 4, right? So the coordination number is 4. So once again, let's do a quick recap. So when you have 3 spheres in the lower layer surmounted by a 4th sphere above them, the gap is called a tetrahedral void. And in a tetrahedral void, the number of tetrahedral voids, the formula is twice the number of constituent particles. And to determine the size of the tetrahedral void, if you draw this diagram, the body diagonal twice capital R plus twice small r is a root 3. And for the face diagonal twice r is a root 2. If you divide it, small r by big R is 0.225. And in case of octahedral void, there will be 3 spheres in the bottom layer surmounted by 3 in the above layer. The gap between them is called octahedral void. And number of octahedral voids is equal to number of constituent particles. To find the size of octahedral void, draw 4 spheres in the bottom layer. And this is the sphere in the middle, radius small r. So twice capital R whole square is small r plus capital R whole square plus small r plus capital R whole square. So capital R plus small r is capital R root 2. So 1 plus small r by capital R is root 2. So small r by capital R is root 2 minus 1. So that is 0.414. And the coordination number for octahedral void is 6. That is number of immediate neighbors. For tetrahedral it is 4. So these are the details of octahedral and tetrahedral void. Okay, so now I am giving you the homework questions based on whatever we have discussed. Okay, I am giving you the homework questions. Okay, the first question of the homework, there is a compound which is made of two elements X and Y. So Y is forming the anions and the anions are located in FCC position. X is forming the cations and they are located in the octahedral voids. So Y is anions FCC, X is cations octahedral voids. What is the formula of the compound? This is question number 1. Question number 2, there is a compound in which the B elements are in FCC position and A elements occupy 2/3 of tetrahedral voids. So B is FCC and A is 2/3 of tetrahedral voids. What is the formula of the compound? This is question number 2. Question number 3, there is a compound ferric oxide which is FCC and 2 out of 3 octahedral voids are occupied by Fe3 plus ions. What is the formula of the compound? So these are the 3 questions based on tetrahedral and octahedral voids, and you can submit your homework anytime before Monday 9 p.m. Tomorrow we won't have any sessions, so you can submit it by Monday 9 p.m. That will be all by all of you.